Welcome to the deep dive. Today we're diving into something that, well, it might seem a bit specialized at first glance, swine diseases,
hmm
but honestly, the things we'll uncover affect everything. Think about the cost of bacon?
Yeah,
Yeah, but also big international trade deals and even uh, public health more broadly.
it's a critical area, often overlooked, like you said.
Yeah, this corner of animal health, it has this huge direct impact on global economies. It's quite surprising.
And what's really insightful here, maybe even a bit alarming, is how these diseases get classified. It's not just about what they do to the pigs themselves.
Right.
It's about their sheer potential to disrupt entire industries, to completely redraw trade maps, and subtly impact human health. They can almost hold global systems hostage in a way.
Wow.
So for this deep dive, you've given us this great stack of sources, really detailed stuff on critical foreign and regulatory diseases, their economic punch, and the latest management strategies.
Yeah.
Our mission today is basically to pull out the most crucial nuggets from all that information, give you, the listener, a shortcut to getting up to speed on this pretty complex topic.
Okay, let's start unpacking that. You mentioned different classifications. So we've got threats we're trying hard to keep out, the foreign ones,
Exactly.
and then the ones already sort of inside the borders,
Okay.
causing this constant background noise, this drain. Why is that split so critical? Is it mainly about the economy for the foreign ones?
It's absolutely fundamental because those foreign diseases, if they get in, we're talking potential economic catastrophe almost instantly.
Yeah.
That's precisely why agencies like the USDA pinpoint specific Tier 1 threats. These are top priority because they could just devastate the industry. We're talking immediate closure of all export markets, mass depopulation.
Which ones are tier one?
The big three are African swine fever, or ASF, classical swine fever, CSF, and foot and mouth disease,
Yeah.
FMD. And you have to understand, these aren't just, sad animal health problems. They are genuine national economic security concerns. They could cripple a, $30 billion industry, basically, overnight.
And many of these are notifiable, right?
Mhm.
Meaning you have to report them.
Yes, absolutely. Any suspicion, any confirmation, it triggers an immediate alert. And often they are foreign animal diseases, FADs, meaning we don't have them here or we got rid of them, but the risk of them coming back is constant.
Okay, so let's tackle the first one, the one the sources call the unprecedented threat, African swine fever,
Yeah,
ASF.
ASF is a big one.
Caused by ASFE. It's a big, tough DNA virus.
Mhm.
And uniquely, it's an arbovirus. It replicates in pigs and soft ticks. That sounds complicated.
It is unusual. Yeah, it adds another layer to how the virus persists and spreads. Ticks can maintain it in the environment.
Right. And transmission,
Right.
super high through direct contact, obviously. But this is the part that really jumped out at me, eating contaminated pork products.
A huge pathway.
The virus survives for months in refrigerated meat, even years in frozen stuff, which makes feeding uncooked food waste swill, feeding a massive risk.
Absolutely critical vector, especially internationally.
Then you've got fomites, contaminated boots, trucks, equipment, and feral pigs running around acting as reservoirs.
All major factors.
And clinically, it sounds brutal. High fever, pigs go off their feed, depressed. You see these hemorrhagic spots like bleeding under the skin, on the ears, snout,
Very characteristic signs.
bloody diarrhea, vomiting, trouble breathing, and the death rate,
Right. Yeah.
near 100% with the really nasty strains. Some even die suddenly before showing much.
That's right. Paracute cases can be incredibly fast,
Yeah.
making early detection even harder.
And this is where the economics just become staggering. The sources project ASF could cost the U.S. economy, between $50 and $75 billion over 10 years?
It's almost hard to grasp numbers like that.
$75 billion. It's not just a problem for farmers anymore, is it? That's a national security level threat. It changes everything.
Completely. It reframes the whole conversation.
And it stems mostly from that immediate export ban, right? Plus the cost of mass depopulation.
Exactly. And the ripple effects. You'd see live hog prices just tank maybe 40–50%, and estimates of like 140,000 job losses across the country. Huge impact.
Okay, but here's the really scary part for ASF. No vaccine, no treatment.
Correct. None currently available that are widely approved and effective.
So is our only defense that stamping out approach you mentioned? What does that actually mean for a farmer if their herd gets hit?
Unfortunately, yeah, that's the primary strategy for eradication. Stamping out means rapid, humane depopulation of all infected and exposed pigs on the premises. Then it's rigorous disposal of carcasses, followed by intensive cleaning and disinfection, strict biosecurity to prevent reinfection, and massive surveillance in the area to make sure it hasn't spread. It's drastic, but essential for FADs like ASF.
Wow. Okay. Moving from ASF, let's talk about classical swine fever, CSF. The sources called it the deceptive mimic. Why mimic?
Right, CSF. It's caused by a different virus, CSFE, a pestivirus, and it earns that mimic label because, especially in the acute form, the clinical signs can look almost exactly like ASF.
So high fever, the hemorrhagic signs, skin turning bluish, maybe some neurological issues.
Precisely. Even post-mortem findings, like button ulcers in the colon, can overlap. It makes field diagnosis impossible. You need the lab.
And there's something else insidious about CSF, right? Something about piglets.
Yes, a really key epidemiological feature. Persistently infected piglets, PI piglets. These animals get infected in the womb, survive, but they shed the virus continuously, often without showing severe signs themselves. They're like silent spreaders.
Oh, that's dangerous.
Very. And like ASF, transmission is direct contact, contaminated pork again, swill feeding is a risk, and contaminated objects, fomites.
Now, here's a twist from the sources. Unlike ASF, there are effective vaccines for CSF.
That's true. Good vaccines exist.
But FED-free countries, like the U.S., still seem to default to stamping out. Why not just vaccinate if you have a vaccine? Seems less costly than killing all those animals.
That's a really logical question. It comes down, again, to international trade rules and maintaining that disease-free status. Using vaccines, especially traditional ones, can make it hard to tell if an animal has antibodies because of the vaccine or because it's actually infected. This complicates proving freedom from disease for export markets.
So even with a vaccine, you might still lose trade.
Potentially, yes, although there's been significant progress with DIVA vaccines.
GILA.
Stands for differentiating infected from vaccinated animals. These newer vaccines allow tests to distinguish between immunity from vaccination and immunity from natural infection. That's a potential game changer for control strategies, maybe allowing vaccination without sacrificing trade status eventually. But for now, in FAD-free zones, stamping out is generally the policy.
Okay, interesting. All right, the third tier 1 threat. Foot and mouth disease, FMD, known as the trade barrier.
And for very good reason.
Caused by FMDV. And this one has 7 different serotypes, like 7 distinct flavors of the virus.
Exactly. A, OC, Asia 1, SAT1, 2, and 3. And immunity to one doesn't mean immunity to the others, which makes vaccine strategy really complex. You need the right match.
And it's incredibly contagious, spreads by direct contact, fomites. And this blew my mind. It can travel through the air for miles.
Under the right conditions, yes. Temperature, humidity, wind. It can spread via aerosols over significant distances. Makes containment incredibly difficult.
And pigs play a special role here, don't they? Something about being amplifiers.
They do. This is a critical point. Pigs, once infected with FMD, excrete massive amounts of virus into the air through respiration. Many, many times more than cattle or sheep do.
So one infected pig farm can become like a virus bomb to the whole area.
Essentially, yes. They are potent amplifiers of the virus, making them super spreaders.
Clinically, FMD is known for the vesicles, the blisters, right? On the snout, in the mouth, and especially around the feet, the coronary band. Causes terrible lameness.
Very painful. You'll see pigs reluctant to move, drooling, maybe making chomping motions because of mouth lesions, not wanting to eat.
Morbidity is high. Lots get sick, but adult pigs usually survive.
Generally, yes. Mortality in adults is low. But it's devastating for young piglets.
Why piglets?
They often develop myocarditis, inflammation of the heart muscle, which is usually fatal. Post-mortem, you see these characteristic stripes on the heart muscle called tiger heart lesions.
But the main economic hit isn't dead pigs, it's the trade, right?
Yeah.
That immediate, total ban on exports.
Absolutely catastrophic disruption. A single FMD case would slam the door shut on billions of dollars in exports of animals and animal products. Instantly. The U.S. has been FMD-free since 1929, and maintaining that status is paramount.
And like ASF, no real treatment. Control is stamping out. Vaccines exist, but again, not usually used preventatively in FAD-free countries because of the trade surveillance issue.
Correct. Using vaccines can mask underlying infection and complicate proving disease freedom to trading partners.
So differentiating these diseases with blisters, FMD, swine vesicular disease, vesicular stomatitis, even something called Seneca virus A sounds tough, just based on looking at the pigs.
Extremely difficult. The clinical signs overlap significantly. That's why immediate submission of samples for laboratory diagnosis is absolutely crucial. You need the lab to tell you what you're dealing with.
Okay. So we've covered these, like you said, lightning strike, FADs,
Yeah.
huge sudden impacts. But what about the ones that are always kind of lurking?
Right, the endemic diseases. These are the ones constantly present in the pig population. They might not cause the same immediate panic as an FAD outbreak.
But they're a constant drain.
Exactly. A persistent grinding drain on productivity and profitability. They cause substantial losses day in, day out.
So let's talk about the big one there. Porcine reproductive and respiratory syndrome, PRRS, described as the persistent economic drain.
Yeah, PRS is arguably the most economically significant endemic disease in many major swine-producing regions, certainly in the U.S.
Caused by PRSV and arterovirus.
Uh-huh.
And there are two main types.
Two species, yes. PRRSV1, more common in Europe, and PRRSV2, dominant in the Americas and Asia. But the real kicker with PRRS is its incredibly high mutation rate.
It changes constantly.
Constantly, it's always evolving, creating new variants. This makes vaccine development and long-term immunity really challenging because a vaccine developed for one strain might not work well against a new one that pops up.
And clinically, it hits in two ways, right? Reproductive and respiratory.
Correct. The reproductive syndrome causes things like late-term abortions, increases in stillborns and mummified fetuses, and weak newborn piglets that often don't survive.
And the respiratory side.
That hits pigs usually after weaning. You see fever, lethargy, sneezing, difficulty breathing, sometimes a very characteristic labored breathing called thumping. That lung damage also opens the door for secondary bacterial pneumonia, which makes things even worse.
And the cost. You mentioned it's the most costly disease in the U.S. since classical swine fever was eradicated.
The estimates are staggering. Over $660 million annually. That breaks down to something like $1.8 million every single day lost to PRRS in the U.S. swine industry.
Wow. Just constantly bleeding money.
It reduces overall production efficiency significantly, maybe 15% reduction, adds weeks, like 14 to 30 days, to the time it takes to get pigs to market weight.
And control is tough because it keeps changing. So what do producers do?
There's no silver bullet. It requires a multi-pronged approach. Strict biosecurity is number one, trying to keep new strains out. Modified live virus vaccines, MLVs, are widely used. They don't always prevent infection, but they can significantly reduce the severity of the disease and limit virus shedding.
So manage it rather than eliminate it.
Often, yes. And specific herd management strategies like herd closure, where you stop bringing in new breeding animals for a period to stabilize the herd's immunity.
Okay. Another endemic one mentioned is porcine epidemic diarrhea, PEDV, the neonatal scourge. Sounds bad for baby pig.
Extremely bad. PEDV is a coronavirus, spreads very easily through the fecal-oral route. Think contaminated trailers, boots, anything that moves manure around.
And the signs are vomiting and really bad diarrhea.
Acute vomiting and profuse watery diarrhea. In older pigs, it causes sickness, but they usually recover. But in newborn piglets, especially those under a week old, it's catastrophic.
Okay.
Mortality rates can approach 100%. They just dehydrate so rapidly. The U.S. had a major epidemic starting in 2013-2014.
I remember hearing about that.
It killed millions of piglets. Estimates were like a 6-7% drop in the entire national pig crop that year. Devastating.
So control there is, super strict cleaning, biosecurity.
Absolutely critical, especially cleaning and disinfecting transport vehicles between loads. And building immunity in the mother sows is key.
How do they do that?
Either through vaccines given to the sows before they farrow, or sometimes through controlled exposure to the virus, a practice called feedback, so the sows develop strong immunity and pass protective antibodies to their piglets through their milk. That's called lactogenic immunity.
Right, protection through the milk. Got it. Okay, one more endemic disease. Porcine circovirus-associated disease, PCVD. This one's called a vaccination success story.
It really is a remarkable example of how effective vaccines can be. PCVD is associated with porcine circovirus type 2, or PCV2.
It is this virus is everywhere.
Pretty much ubiquitous, yeah. Found in most swine herds globally. But interestingly, just having the virus doesn't always mean you get the disease.
What triggers it then?
It often seems to require other factors, like co-infection with other pathogens, like PRRSV or bacteria, or some kind of immune system stimulation or stress. The virus itself targets immune cells, leading to immunosuppression.
Making the pig vulnerable.
Exactly. The main clinical form used to be called post-weaning multisystemic wasting syndrome, or PMWS. You'd see young pigs just waste away, stop growing, have trouble breathing, diarrhea. Their lymph nodes would get visibly enlarged. There's also a skin and kidney form called PDNS.
And this used to be a big problem.
Oh, huge. Back in the late 90s, early 2000s, before the vaccines became widely available, PCV8 was causing massive economic losses. Post-weaning mortality rates could easily exceed 20% on affected farms.
30%.
Yeah, it was crippling for many producers. But then came these incredibly effective vaccines, both inactivated whole virus and subunit types.
And they worked.
Transformatively well. Routine vaccination of piglets became standard practice, and it dramatically reduced the prevalence of clinical disease, slashed mortality rates, improved growth performance. PCVA went from being a major crisis to a largely manageable condition. It's a real testament to vaccine technology.
Okay, so we've got these massive foreign threats, these constant endemic drains. What does this all mean for protecting the industry as a whole? How do you defend against all this? Sounds like you need a system.
You absolutely do. It's not just about tackling one disease at a time. It's about an integrated framework, a whole philosophy of health management.
Right.
And this framework really rests on three critical pillars. The first, and arguably the most important, is foundational biosecurity.
Okay, this is seen as the single most critical and cost-effective strategy overall. It's not just a checklist anymore. It's evolved into this comprehensive operational philosophy of managing risk.
What does that mean in practice, like boots and coveralls?
That's part of it, but it's much bigger. It involves defining clear zones. You have the perimeter buffer area, the PBA, that's the outer zone controlling vehicle traffic, deliveries, people coming onto the site.
Okay.
Then you have the line of separation, the LOS. This is the critical boundary around the actual animal housing. Crossing that line means strict procedures, showering in and out, changing clothes and boots, disinfecting any supplies coming in. It separates the clean inside from the potentially dirty outside.
Very structured.
Absolutely. And focusing on the highest risk pathways for disease entry. That includes animal movement, quarantining. Any new animals coming onto the farm is essential. Feed and feed ingredients. We talked about how viruses like ASF and PEDV can survive in feed, even across oceans, so sourcing and handling feed carefully is key.
Yeah, that's scary. Transport vehicles are huge vectors. Trucks need rigorous cleaning and disinfection between loads. And feral swine and wildlife, they can carry diseases, so robust fencing and good pest control are vital parts of biosecurity, too. Think detailed visitor logs, dedicated disinfection rooms for equipment. It's a whole system.
Okay, so biosecurity is pillar one. What's pillar two?
Pillar two is strategic vaccination and immunization. It's a powerful tool, but it complements biosecurity. It doesn't replace it.
Right. And we touched on this. Effectiveness varies, right?
Exactly. Vaccines work incredibly well for relatively stable viruses like PCV2, as we discussed. It's a game changer.
But for others?
For highly changeable viruses like PRRSV or influenza A, vaccines are more nuanced. They can definitely reduce the severity of illness, limit virus shedding, help manage the disease, but they might not always prevent infection altogether. It's about controlling the impact.
And for gut diseases like PEDV.
Enteric disease vaccines, like for PEDV or TGE, often have more inconsistent results. They mainly aim to boost the sow's immunity so she can pass protection to her piglets through milk that lactogenic immunity again.
And there are different kinds of vaccines. Live ones, killed ones.
Yep. Modified live virus, MLV, inactivated or killed vaccines, subunit vaccines, which just use a piece of the virus, like some PCV2 ones, and even autogenous vaccines, which are custom-made using virus strains isolated from a specific farm to tackle a specific problem there.
So it's not one size fits all.
Definitely not. Vaccination programs have to be tailored to the specific herd, its health status, the diseases circulating in the area. It requires close work with a veterinarian and constant monitoring to see what's working.
Okay, biosecurity, vaccination. What's the third pillar?
The third pillar is surveillance, diagnostics, and response. This is all about gathering the intelligence needed to stay ahead of threats, both existing and emerging.
Like knowing what's coming.
Exactly. It involves monitoring efforts, both nationally and globally. You have organizations like the Swine Health Information Center, SHIC, in the U.S. Their job is to track disease outbreaks around the world, identify potential new threats heading towards North America, and provide early warnings.
Their early warning system.
Precisely. Then you have government agencies like USDA, APIS, running their own surveillance programs. They routinely test samples from sick pigs submitted to labs, from pigs condemned at slaughter, and importantly, from feral swine populations, specifically looking for those high-consequence FADs like ASF, CSF, and others like pseudorabies.
And if they suspect something, diagnostics.
That's where the lab network comes in. The National Animal Health Laboratory Network, NAHLN, is a system of state and university labs across the country. They provide the capacity for high-throughput, rapid testing, often using techniques like qPCR.
But for the really serious foreign diseases.
For a suspected FAD, the samples go to the top-tier federal labs, USDA's National Veterinary Services Laboratories, NVSL. That includes the Specialized Foreign Animal Disease Diagnostic Laboratory, FADDL, historically at Plum Island, now transitioning. They do the definitive confirmatory testing for FADs.
And if the worst happens, if an FAD like ASF is confirmed, response.
Then the emergency response plan kicks in immediately, and it starts with reporting. There's a legal and ethical obligation for anyone, vets, producers, to immediately report suspicious signs like unusually high death losses, blisters, weird neurological symptoms to their state animal health official.
Don't wait.
Absolutely do not wait. That report triggers an investigation, an immediate quarantine of the premises, rapid diagnostic workup, and if an FAD is confirmed, then you implement that stamping out policy we discussed. Depopulation, disposal, cleaning, disinfection, and really intensive surveillance in the surrounding area to ensure containment. It's a massive coordinated effort.
Wow. It's clear, then, that protecting this huge global industry isn't just about having a vet give a shot. It's this constant, really complex battle fought on all these fronts: prevention, intelligence, collaboration.
That sums it up perfectly. It's a continuous effort requiring vigilance at every level, from the individual farm to national and international cooperation.
It really is a testament to the resilience needed in that sector, facing down these kinds of pervasive threats all the time.
And, this raises an important question, maybe, for you, the listener. When you consider these immense economic and social stakes we've talked about, the billions of dollars, the jobs, the food supply, and you see how pathogens constantly evolve, how might these kinds of integrated strategies that focus on relentless biosecurity, smart immunization, and rapid intelligence and response, how might those ideas apply elsewhere, maybe to other industries, or even to human health challenges you encounter?
That's a great point. Think about that. The resilience of a whole industry hinges on this unwavering commitment to prevention, intelligence, and working together. It's actually quite fascinating when you break it down like that.